before you started this course, if you had heard of Newton's second law at all, you most likely had heard it stated as F equals ma. We have mentioned plenty of times the m part, the mass of our system, and the F part, which more precisely is better written as F net, the total pushes and pulls on our system. But the A part, which you may know is called the acceleration, has been MIA, missing in action. What is the acceleration and where has it been? We'll spend a bit of time here answering these questions. Recall when we first introduced Newton's second law, we wrote it down in the form of the change in the velocity over the change in time is equal to F net over m. We've described how this is an amazing secret of the universe, and it bridges quantities we obtain by watching an object move during some period of time and combining that with a property of the object, connecting that with something very different, a measure of the total influence of the surroundings on the object's motion. We've emphasized the central role that velocity plays here. Velocity, which tells us both how fast an object moves and in what direction it moves. Now, the change to the velocity is the key signature that the surroundings are having a net influence on the object's motion. If the object's speed changes, or if the object's motion changes direction, or both, these are velocity changes and therefore can only happen if the surroundings have a net non-zero influence on the object. If the object moves at constant velocity, then there is no change in velocity and therefore no net change, no net influence of the surroundings. Now, with all this firmly in mind, we can now say that the acceleration is really an old friend. It's something we've been dealing with all along. The average acceleration, a vector quantity, is just defined as the change in velocity over the change in time. It's just another way to label the left-hand side of Newton's second law as we have written it here. We may also say that the acceleration is the time rate of change of the velocity. So we've added some new words, some new vocabulary, but notice we haven't added any new physics content. When we say that our object's velocity changes, speeds up, slows down, and/or changes direction, as we observe it for some period of time, that's exactly the same thing as saying the object is accelerating. And when we say that our object's velocity does not change, it keeps moving in the same direction at the same speed, then that's exactly the same thing as saying the object does not accelerate. The object has zero acceleration. We have chosen to emphasize first the importance of changes, speeding up, slowing down, and/or changing direction, directly connected to the quantity that's changing, the velocity, because in our view, it's better to visualize that first before using a more abstract description like non-zero acceleration. As a final point, let's emphasize the role of observation here. Acceleration is obtained directly by just watching an object move because acceleration is nothing more than observing the velocity changes over some change in time. So this statement relating acceleration to the change in velocity over the change in time is just a statement of definition. It just gives us two different ways to state the same observation. By contrast, the statement of Newton's second law, either in our original form or using acceleration, is a very different statement. It's a law of nature, not a definition. We believe this to be true because countless observations and experiments have verified that it's true. So let's not fall into the trap of thinking that this statement defines acceleration. This statement defines acceleration, a relabeling of the quantity delta v over delta t. This statement is not a definition. It's a secret of the universe. Bottom line, using the word acceleration gives us extra vocabulary to use to describe motion. And it's good to know, if for no other reason, than the word acceleration has such widespread usage. We'll be using this wording from time to time because it's good practice. However, it's always good for us to translate the word acceleration into its meaning in terms of velocity changes so that we can develop a better intuitive feel for the meaning of acceleration whenever we use it.